Hello folks, it is BatTube here, and this is a video kind of in response to another video of mine that you guys may have seen about repairing an e-bike battery. Now in that video I needed a spot welder, which I knew I had one, but it sucked because I got the cheap one off of Amazon. It's actually really not cheap. It's about $150 to $200 plus, but it still sucks. It doesn't even barely work on max settings. This is any of the Sunkko 788H, don't mind the burning. LiPo battery blew up in front of this and it kind of melted the front. But basically any of the Sunkko models, I'll put a couple on screen right now. This video is basically going to apply to you guys. You guys have probably noticed that the performance sucks. You've got all of these settings maxed out on the pulse and right here. And it's just not working. So what you're going to do, you're going to take this apart. As you can see, I've already gone ahead and taken it apart just to make this video go by a bit quicker. These are the pieces that go in the front. There's a pin in between them, as well as the wires are screwed in on the bottom. So you're going to have to go inside and wiggle these, probably push them in. By taking out the probes, push them in, flip them upside down, get the wires out, and separate these. Now I kind of reversed so I could show you. Next you're going to find this clip right here. First of all, obviously, this thing better be unplugged. You should not be even taking off the side panels until it's unplugged. And the side panels, they're just side screws. There's no hidden screws anywhere, so that's easy for you. So anyways, you just go inside, undo this clip, and on this transformer that you can see I've already undone, there's going to be a positive and a negative right there. And you can either decide to cut the wires if you don't have the means to soldering, or you can unsolder them like I did. I just remember their positions. After you do that, you can put this clip to the side completely. Next, the transformer is held in by 4 screws. One here, one here, one here, one here. There's going to be a nut on the inside and a Phillips screw on the opposite side on the bottom that you can unscrew to take it out. I've got all of that unscrewed, so it's all nice and loose. Once you got all of these wires disconnected, you will still notice that there is a probe stuck in here. All I did, I broke these 2 plastic tabs that you will notice in yours still has. So if you break those off, you should be able to snugly pull this temperature probe out and separate that. Just make sure that the transformer isn't overheating. You're going to want to install that later. What we're going to be doing here is upgrading the transformer, which I've already done, to show you guys better. Okay, so this is 6-gauge wire. Both of these leads are 6-gauge wire. And what on your transformer, all you're going to see is this winding right here. And what you're going to be doing is taking a piece of wire, another 6-gauge wire, like this one here. And you're going to take a knife and you're going to slice it all the way down, being careful not to slice the copper until you have a bare strip of wire. Now you can either wrap it with heat shrink. I went ahead and used Captain tape or polyamide tape. That is electrical insulating tape. It's also able to withstand up to 200 degrees Celsius of temperature. So that's good. Celsius or Fahrenheit, I can't remember. That's a big difference, so don't quote me on that one. But it's a high temperature electrical insulating tape. So I did layers overlapping one another, at least one full time. And then afterward, I pressed on this wire to make it more flat. And the reason being is because the slot that you have to slide it through is very flat. So instead of a round wire, you can use either your fingers or a pair of pliers to flatten the wire so it's more of a obviously flattened plane. And you can go ahead and wrap it the same amount of times. As you can see, it goes through, it wraps around one full time, it wraps around once, and halfway. Okay, so the amount of times you're going to wrap this wire, you're going to push one end through completely, and you're going to pull it all the way out the other side. until you have just enough hanging out that's going to match the opposite side. You pull that, you bend it around, push it through, bend that around, push it through, and then once again push it through to come out and meet this one. I will give you some visuals so you can match yours to this. As well, the back, you will see there's 2 wraps showing on the back. All you have to do now is combine these 2 wires. I'm not going to be doing a by means of soldering, anything like that. But what I'm going to be doing is a method using thin copper wire to tightly bind the wires together, kind of like a finger trap, and it's going to provide pretty good contact. So this part is ready. I'm just going to set it in here for now because we're going to have to pull it out again when we wrap the wire. But we want to get the wire prepared that we're going to be wrapping. As you can see, I have 2 of these connectors. 2 of these large Anderson connectors. These are the Anderson. I will put the actual rating on the screen, and there will be links in the description where you can get these types of connectors. Just keep in mind they are probably Amazon affiliate links that I may or may not make money off of if they are affiliate links. Okay, so these ones actually came off of, I believe they came off of go-kart batteries or golf cart batteries, so they actually have wire already on them. So in your case, you will probably have to wire some 6-gauge wire onto it. So what I'm going to be doing is having this spot welder disconnectable, so it's easy to store on a table. So I want the Anderson cable to stick out the front, kind of like that, put it in the center, and this can be plugged in, like so. And on the end of this is going to be the pen, which we are going to be making. So what I'm going to be doing is, because we have all this extra wire, we don't need it. And a very important part here is because this puts out fast pulses of high current, the smallest length of wire, the better. So you want to use the least as possible. So I'm going to run these cables through. And I want the Anderson connector basically like that. There's no way I can make it any better due to the circuit boards inside of the machine, but it's still less of a presence than these were when they were sticking out. So either way, it's a win. So all we gotta do is take the shortest wire, and if you can see, we've got it matched up right there. So right at the end where we've got it matched up is where we want to cut it. So I'm gonna grab a permanent marker. I'll zoom in a bit so you guys can see this a bit better. So for this side, these 2 wires are going to join together, and this red wire is going to join this one over here, kind of like so. And we kind of want a bit of an excess, but not much. So right where my finger is the end of this wire. So that's where I'm going to mark it. And I'm not even going to mark the opposite side. I'm just going to use the identical length that we did here. So now that we have those marked, we can cut our wires. Now scissors provide a different type of stress, a shear stress, which is much better in this type of situation for cutting wires instead of side cutters. And there, look at how much shorter it is. And that's going to guarantee that the high currents are going to make it all the way to the pen side. Now what I'm going to do, I'm going to strip back some, taking the knife. It's about 1 inch that I'm stripping back, maybe 1 inch and a little bit. And I'm cutting down just until I'm on the inside, trying not to cut any of the wires themselves. As for the side cut, I will only start it. I'll just push the blade in a little bit. And then when I start to peel this, I can manage to get the copper wire out. Sorry you guys didn't see that, with that little lip that I cut out. You guys probably didn't even see me cut. Keep forgetting how zoomed in I am. Same thing on this side. Peel it back where I put the blade into. Open it up. And get that copper wire out. I have separated the copper wire from the shielding. Now I can cut it off. Alright folks, I've got some apple cider vinegar here because I don't have regular vinegar. It's what we're going to use to clean the copper wires before we wrap them together. This is what we're going to be using to wrap them together. It's like some 30 gauge, very low gauge or high gauge, depending on how you think about it. Very small solid wire. I got this from a 30 by 4 telecommunications line, 4 line. I just stripped the wire to get the solid copper out, and that's what we're going to use to tie the joints very tight. So using a rag, I'm going to take my vinegar. I'm going to put a decent amount. And the reason I'm going to put a decent amount is because what I'm going to do, I'm going to wrap around the wire and I'm going to squeeze. And what that's going to do, it's going to pass the vinegar through all the copper threads because there is a lot of vinegar inside of it, inside of the rag. So we're kind of using the copper like a sponge so it can absorb the vinegar. We're going to wipe that a couple times. You can wipe the ends here. This isn't 100% necessary, but when you're dealing with high current like this, any bit of conductivity gain or lack of loss is a positive. It's gonna prevent heat from building up here and keep a lower resistance. So now that that's done, I can basically leave it. It's gonna be wet for a tiny bit, but now our hands. We are going to be touching this wire again, so I'm just gonna take some rubbing alcohol and clean my hands. The reason being is I'm going to get rid of the immediate oils on my skin, which is going to tarnish the copper. So this is only a temporary thing, but it's going to get rid of the skin oils. So this part's going to be a little bit hard. I'm going to push the wires through. I kind of do wish I did leave myself a tiny bit more wire, just because it would have made this easier. So what you want to do when you do this, you want to start lower down, which is what I might do right here, as long as it's going to work the way I want it to. So I got the wires very tight, as you can see. They're way past each other. It's basically the end to the end. What we're gonna do is wrap this lead around, get it as tight as we can. I'm gonna wrap that lead around and pull it the opposite way. Ouch. That went right into my finger. 30 gauge wire directly into the finger, which isn't really that small. So making sure the strands are staying straight. Holding the wire once you get around, hold it tight, hold it tight, this around, tight, hold the fingers, wrap around, tight. Okay. So right about here is when I'm going to put this one in. Just like this. And the wire is going to hold itself as long as we keep tension on the end of it. So while maintaining tension on the wire, I am now going to completely wrap it. As tight as possible, be careful with the wire, as it's very thin, it's thin, people aren't too tight, so just be careful. I sometimes find these connections almost better than soldering. One of the things you can also do, now that you have this joint held, you can actually put some solder there now if you want, and it would actually be much easier now. We're using copper wire all around, so you could easily fill this with some solder. The only reason I'm not is I really don't have that much solder or a solder big enough for this application. I would end up using basically all of the small stuff that I have. So now that I'm at the end, I'm going to put it underneath itself. So you push the current end under the last one, if I can get it there. And you grab some pliers, bite it, and then turn your pliers this way. And then pull. And that's going to make a solid joint. And that you can just wrap up there. This is all going to get wrapped with electrical tape now, so it's going to be all sealed. You could use heat shrink if you want. I figured I'm just going to use electrical tape because I can get the perfect amount that I want. Alright, so the first one is complete. That wasn't as hard as I thought. Once you get that wire around it, it's just easy wrapping from there. So I'm going to go ahead and do the same on this side. Start off there, wrap the wire, and wrap that all up. Beautiful. Alright, so now the transformer is complete. It's completely complete. Now the only thing we have to do is put these wires back on. So I'm going to fire up the soldering iron. We got a negative that goes here, and a positive that goes here. Now the negative, there's 2 pads there, and the negative is going to take up both of those pads. Alright, so I believe the soldering iron is fired up, so it should be ready to do this. First I'm going to fix up these 2 pads here. That is ready. Negative goes right there. That is leadless solder, which I hate to work with. Very weird to work with. I'm just not that familiar with non-leaded solder. Okay, so those are both soldered. Could be looking better, but my eyes are having a really hard time right now. I may need some glasses or something. That's ready to plug in. So we have this thermal probe here. I'm going to slide that right back in where it was. This is just checking the temperature of the wires in the transformer, making sure they're not overheating, which is quite important, honestly. Let's get this transformer back situated. Be mindful of the ground right here that goes in that screw hole. Alright, so using some needle nose and some persuasion, I got all 3 of them tightened, obviously because the one went down my furnace vent, and it's fine with just 3. Okay. So now that the insides on this are done completely, which is kind of a relief, we can close this up and worry about our pen. So coming in with the lid, making sure it's going on the outside of everything, just like that. So there are some different screws. There is going to be some flat top screws, that is for the metal connections. And there's going to be some pointed tip screws, and that's for the connection into this plastic front housing. Alright, so first of all, I do want to test just if this is going to work. It's not going to blow any 15 amp breaker, and in order to run this thing, due to our house having old wiring, I have to actually wire this to breaker outside because there is way too much load on this current 15 amp breaker. It's like several rooms in the house. So I've got a 2-cell setup to test the spot welder. So I made my own probes using some 12 gauge solid copper wire. I just shoved some into the ends of these connectors that I have. I left one end longer than the other, just so I can have the main cell that I'm going, and this one can have some space so it's not so cramped up to that one. So I will show you how it works now. And honestly, this is the easiest way. There's one. There's 2. I actually had a puncture, so you actually had a single solid connection on that, and nicely done. And that is stuck right on there. It actually punctured on 3 of the 4 contacts. Alright, so that's how you take the piece of crap Sunkko spot welder and turn it into something decent. You can experiment with the connector. Obviously this is going to be a point of resistance. If you want, you could eliminate the connector altogether and just go with some solid cable from the inside. You might end up with better welds than I'm getting. Make sure all the contacts are clean in these Anderson cables and such. Make sure you have a somewhat flat tip with a slight point or an edge on the end of your welding probes. Alright guys, thanks for watching. I hope this helped you guys out. In the future, I would like to put a whole new transformer in here altogether, a larger one that can handle more current without even having to mess with the transformer. As you can imagine, a really good place to get one of those would be a microwave, so I'm going to be having a look around, and we'll probably put a fan in here and stuff. But this is how you take the stock Sunkko, any of the Sunkko spot welders, and upgrade them with some simple 6-gauge wire and some other 6-gauge or 4-gauge wire. I would suggest using solid copper wire and not copper clad aluminum. If you do use copper clad aluminum, use a lower gauge, maybe like most definitely a 4-gauge instead of the 6-gauge. I would go with maybe a 4-gauge or a 4-gauge altogether, or maybe 6-gauge altogether. Alright guys, thanks for watching. Have a great day.